Good morning. It is Tuesday morning, April the 12th. It is time for PLAR History and Geography with myself, Jonathan, your teacher for this course. It is week number 9. Yes, this is the last week number 9, last week for this term, term 2A. So, if you have not completed the PLAR subjects you have been working on, you will not be withdrawn and you will not have to reapply for term 2B. You do not have to resubmit your work, just continue where you left off, but choose the subject you have been working on the most or have completed the most and finish that one off first. So, for example, if you are working on PLAR English and PLAR History and Geography at the same time, and you're almost done PLAR English, for example, finish that one off first before you continue and work on the next subject, for example, History and Geography. Okay? So, we're almost at the end of this term. We've got this week left. So, really work hard on finishing where you can. Again, if you have any questions, please contact myself in regards to PLAR History and Geography. Contact Jovi for PLAR Science, Bonnie for PLAR Math, and Andrea for PLAR English. Okay, so I know students are working on more than one course at the same time, which is great, but please finish up the subject or the course that you have completed the most. That way you can finish that one off, write the test, and then move on. Okay? Because there's only one term left before the summer. Pretty much we start again next week for term 2B. There's no admin week. So please continue to work on those assignments and please continue to complete them. Again, like always, feel free to listen and watch. Feel free to call in the Wausau studio, 1-800-465-7144. You can listen to us on the radio, 91.9 FM. You can log on to the Bridget software, and you can see my smartboard screen live and see all my notes, all my slides, all my illustrations and pictures. You can also go onto the archive website and download the lesson and listen to it by MP3 file, or you can go to my YouTube channel where I post all my lessons, and it is also posted on my Facebook page. Again, feel free to call me during my office hours. Feel free to stop by the Wausau office in Silicon on Front Street next to the post office. Send me an email at jho@nnec.on.ca. Facebook me at jho, capital J, capital H-O, Wausau. And my YouTube channel name is the same thing, jho Wausau. Okay? Again, if you don't have internet access or just want access to a USB stick that has all the lesson, you can just ask me. It is for free. Okay, I will pop all the lessons and whatnot onto a USB stick. I will put it in folders, indicating which lesson, 1, 2, 3, 4, and 5. That way you can access it at home, at your learning center, and whatnot. So you don't necessarily always need internet access if you need help while completing your assignments. Okay, so to get a USB stick, just let me know. That goes for all PLAR subjects, science, math, and English as well. Just ask myself or ask your teacher, and we can get that set up for you and send it off on the express. Okay, so many ways to get access to the class, to the content, to the material. All you need is just let us know. Okay, we're here to help. We're here to help. Okay, so again, free USB stick for free with all the lessons. If you want all of them, all subjects, we can do that too. Again, just let us know. All right. So today, we're going to talk about lines, imaginary lines. Not real lines, but imaginary lines. Lines that are not always there. Okay, but we're gonna go back and look at geography and link it back to geography. So our final lesson or class material content that we need to go over for the geography half for lesson number 5 is latitude and longitude. Okay, that is our focus for today and possibly for a bit on Thursday. Latitude and longitude. Okay, pretty straightforward to remember the difference. Okay, we'll be also going over assignment number 16. So please make sure you have a good understanding and be able to differentiate the difference between latitude and longitude, how they are different. Once you have a good understanding of what they mean, there shouldn't be any problems. Okay, so let's get to our learning goals for today. Again, I already went over pretty much our focus. Again, we're looking at latitude and longitude. Latitude, longitude, that is our focus, our main focus. But we will be also looking at different terms such as the equator and another fancy term known as the prime meridian. Okay, our directions, and we'll be looking at maps. Okay, that is our main focus for our last class content material. Latitude, longitude, the equator, prime meridian, directions, and later it all back looking at maps. So by the end of today's class, students will be able to locate major topographical features on a map or on a globe. Okay, that was a focus. You'll be able to locate latitude, longitude, the equator, and the prime meridian. Okay. So let's start things off by looking at how to find on an exact location on a map or on a place. How do we find an exact location? So we know our Earth, our globe, our planet is massive, it's big, we have many continents, many countries, bodies of water, and etc. Okay, our planet, the Earth is just massive. Okay, so I'm gonna pose a question and say, how do we locate a particular location or a specific location on Earth? Okay, how do we locate a particular or specific location on Earth? What if you wanted to tell a friend the exact location of Sioux Lookout, Ontario? Okay, so most of us know where Sioux Lookout is. It's pretty much located in northwestern Ontario, kind of westwards, kind of northwest of Thunder Bay. Okay, but then again, that's still hard to describe. Okay, people know it's west of Thunder Bay. People know it's north, but we don't know the exact location of Sioux Lookout. Okay, it's pretty hard to describe. People say, oh, it's just an hour drive north of Dryden. Okay, but then again, it's still hard to put that into perspective. But we want to tell the exact location in regards to on a map or on a globe. So what we need to do is we need a system. Okay, we need a system that is related to math. Okay, so now we are integrating prior knowledge in terms of math. We need a grid system with coordinates. Okay, so if you have been taking Bonnie's PLAR math, that prior knowledge in terms of math would definitely help us in terms of understanding today's goals of latitude and longitude. Okay, so we need a system that is really similar to math, okay, but it relates to a grid system with coordinates. Okay, so on my screen, on the left hand side, you simply have a grid or chart paper, for example. Okay, we've seen this all the time, especially in math, where you're graphing materials. Could be a line graph or a bar graph. Okay, simply a grid. Okay, a grid with coordinates is my other picture on the right hand side. Is where we have, in terms of math, it's known as the y-axis and the x-axis. Okay, so this line right here, this red line I'm going to draw down the middle, this vertical line, in terms of math, it is known as the y-axis. And this other line that goes straight across the middle, this blue line I'm going to draw that is horizontal, is known as the x-axis. Okay, sounds familiar, especially in terms of math. Okay, you have been graphing line graph, bar graph, linear equations, and whatnot. So you do it on chart paper, on a grid, and you need to plot and draw the y-axis and the x-axis. Okay, so when going back to latitude and longitude, it's really similar in terms of what the y-axis and what the x-axis represent. Okay, we're going to give it different names in terms of geography, in terms of today's lesson. Okay, but again, think back to math, use that prior knowledge, and it should really help understand the difference between latitude, longitude, equator, and the prime meridian. Okay, so a grid. Okay, this is a grid with coordinates right there. Okay, y-axis, x-axis. Keep that in the back of your mind as we continue. So now I'm going to take this grid right here and I'm going to pretty much plop it on a map on the globe. So right now, imagine a globe. Okay, we know a globe is in a sphere shape. Okay, but if we were to unfold that sphere of the Earth, of the globe, and make it super flat, it'll look something like this on my screen. And if we were to throw a coordinate onto it, it will look something like this. So now we have a map of the globe, of the Earth, with a grid. Okay, note the lines. Okay, same thing as a chart paper, as a grid. Okay, we still have the y-axis and the x-axis. Again, I can draw it again. So right down the middle, right here, again, we still have something known as the y-axis in terms of math terminology. And the blue horizontal line across the middle of the globe is at the x-axis. Okay, vertical line down the middle in red, y-axis. Blue line horizontally across the middle is your x-axis. Same thing, just apply that math knowledge when looking at a map with the grid. Okay, so still have all the continents: North America, South America, Africa, Asia, okay, Arctics. Okay, same thing, take that map, the globe that's in a sphere. If we were to unravel it, make it super flat, and draw these imaginary lines on it, we'll have a map with the grid. Okay, so let's hopefully that all kind of makes sense so far as we progress and as we continue. But before we do that, we need to know our sense of direction. Okay, let's get to knowing our sense of directions. Okay, so on my screen, yes, we got directions. This picture right here is otherwise known as the four cardinal directions. Okay, our four cardinal directions simply north, east, south, west. Okay, hopefully we heard that terminology before. It's pretty much everywhere nowadays, especially in some fancy cars, especially while you're driving. It'll indicate which direction you're going, or if you have a GPS or an app on your phone. Okay, you can pull it out and know which direction you're headed into. Okay, so north, east, south, west. Okay, it comes in very, very handy. So what we need to know is simply the four directions. Okay, north, east, south, west. So in terms of the four cardinal directions, it goes in a clockwise direction. Okay, it starts from the north, then it goes clockwise. So north, east, south, west. Okay, if we're not sure, there's different acronyms to help us understand. So you can go, for example, whoa, hold on here. Let's use a different color. So we can go never eat shredded okay, something that I learned back in my day that still stick in my head is never eat shredded wheats. Okay, if we have a hard time remembering what goes where in terms of direction, think of a circle, think of a clockwise motion. Okay, at the very top, it's north, so never eat shredded wheats. So eat stands for east, S, south, and then W for west. Okay, never eat shredded wheats, north, east, south, west. Okay, but in terms of today's class, we need to focus on the north and south lines and the east and west lines. Okay, those are the two main lines that we really need to focus on. Vertical lines and horizontal lines. Okay, lines that goes up and down, north and south, and lines that go side to side, east to west. Okay, but again, still make sure we know our forward direction, north, east, south, west. Never eat shredded wheats. Okay, our forward directions. Okay, man, there's so many other acronyms out there. Never eat soggy waffles. That's another one, but there's just so much more. Okay, north, east, south, west. Those are four cardinal directions, and we really need to know our sense of directions in terms of looking at latitude and longitude. Okay. So we need to define two fantasy terms before we continue looking at latitude and longitude. So the equator and the prime meridian. We need to define those two terms, what they mean, and where they are located on a map and on a globe. So, going back to our other subject knowledge in terms of math, we're going to look at the equator, and we're going to look at the prime meridian. Okay, so going back to math, the equator is simply known as the y-axis. Okay, if you can remember, equator represents proximity to the x-axis, you're in good hands. Prime meridian, same thing in terms of math, it equals the x-axis. Okay, same thing. Okay, different terms, different terminology, different names. We're looking at geography, we're looking at latitude and longitude. Okay, so we're going to switch names instead of saying it the x-axis and the y-axis. We're going to call it the equator and the prime meridian. Okay, so the equator is simply a flat horizontal line that goes across our globe. It's imaginary. It's not there. Again, all these lines that we're talking about are imaginary. They're not there. Okay, Equator, horizontal line, across the middle of the map of the globe, similar to the x-axis. Prime meridian, same thing, similar to the y-axis. Straight vertical line down the middle of the globe. Okay, so let's get into a bit further details before we continue looking at latitude and longitude. The equator. The equator. Again, it's an imaginary line that circles the middle of the Earth in terms of horizontally. Okay, I'll write this out horizontally. Okay, the purpose of the equator is that all north and south directions are measured from the equator. Okay, so this red line right here that's across the map, this is the equator. Okay, otherwise known as the x-axis in math. Okay, don't get confused. Okay, that's the equator. Across the middle, again on this little picture right here, across the middle. Okay, in terms of distance, for some fun facts, it is about 40,075 kilometers long in terms of perspective. Okay, it's perpendicular line. Again, imaginary line that circles the middle of the Earth horizontally, and is used to measure distance north and south from the equator. Okay, so now we know where the equator is, where it's located, its purpose. We can use it in terms of where to measure in terms of north and south. So going back to our sense of direction, anything that's above the equator, it's simply north. Okay, and anything that's below the equator, or south. Okay, we use the equator to measure how far you are away in terms of north and south. So for example, here in Silicon in Canada, in Ontario, or somewhere located right here on this dot, so simply we are located north of the equator, whereas anything below the equator is south. Okay, the equator is super unique because, again, our globe, our Earth, is in a sphere shape, and since the equator is in the middle, it reflects off the sun, or sun shines on the equator greater. So if you're living near the equator, or as we approach the equator, it is a lot warmer, it is always hot in terms of climate, in terms of weather. Okay? Whereas if you go further north or further south of the equator, the temperature decreases as the sun shines, has to go a farther distance, hence why it is always colder. Okay, it's colder. Okay, so that's the equator. Okay, I'll say it again. It's an imaginary line that circles the middle of the Earth horizontally. It is used to measure the distance north or south of the equator. Okay, again, x-axis in terms of math. Okay, so let's look at the prime meridian. Prime meridian, again, like I already mentioned, is an imaginary line that, once again, it runs pretty much vertically down the middle of the Earth, okay, of the sphere of the globe. And it pretty much starts at the North Pole and the South Pole. Okay, so again, this line right here, I'm going to draw in red. is the prime meridian, also known as you guessed it, the y-axis in math. But again, we're using this term and calling it the prime meridian. Okay, get used to calling it the prime meridian. Again, vertical line down the middle of the Earth is imaginary. Starts at the North Pole, it goes all the way down towards the South Pole. Okay, think of it as that. Again, on this illustration over here, it's over here. Okay, vertically line the middle. Okay, what's unique about the prime meridian is that in terms of our direction, anything on the right hand side of the prime meridian is known as east. Okay, and on the left hand side it is west. So again, here in Canada, in Silicon and Ontario, we are located west of the prime meridian. Okay, we're on the western sphere, the western hemisphere of the prime meridian. Okay, so now we know the difference between the equator, the prime meridian, and what those names are, and how it relates back to math. We can now look at the difference between latitude and longitude. Okay, so let's get to that. Okay, so vertical line, I'll write that out before we continue. Vertical line, down the middle. Okay, latitude. All right, our main focus today. Again, pay close attention, class. Again, you need to be able to know the difference between latitude and longitude in order to do assignment number 16. Okay, very, very important. Very important. You need to know all of these points. Okay, make sure you know them all. Okay, so latitude, again, are imaginary lines that goes on a map on a globe. These lines, the latitude lines, runs east and west, okay, which means that they are horizontal lines, okay. They are parallel, okay. You may have heard that terminology in math again. Parallel lines, which means that they are the exact same distance, pretty much the exact same. So the latitude lines are parallel lines. They have the same distance apart. And the purpose of latitude lines are they are used to measure the distance north or south of the equator. Okay, this one's really important right here. Put a little star beside it. I'll underline it. Okay, latitude lines are used to measure the distance north or south of the equator or from the equator. Okay, so how I like to remember latitude is that I like to use it known as flats for flats. Okay, think of flat lines when looking at latitude. Okay, always think of horizontal lines. All right, again, horizontal line. Okay, horizontal line, flat lines. Okay, latitude. Okay, so when looking on a map on a globe, the lines that are flat, lines that are horizontal on a map, they are latitude lines. They are parallel, same distance, and they are used to measure how far you are north or south of the equator. Okay, can't emphasize that enough. Okay, so I do got some pictures to help further deepen our understanding. Okay, latitude, again, right here we have the equator. Okay, I'm gonna put in red. This imaginary line that goes across is equator, the equator, sorry. Latitude lines are these lines, again, they are flat, they are horizontal, and they used to measure the distance, how far you are north or south from the equator. Okay, the measurements that we use in terms of latitude and longitude are measured in degrees. Okay, almost like angles or protractor at different degrees. So the equator and the prime meridian starts in the middle, which starts at 0 degrees. And as you continue working your way up, it looks at towards 90 degrees. Okay. So again, latitude lines are these lines that I'm going to draw in green. Okay, these lines right here, they're used to measure how far you are, or how south you are, north or south you are from the equator. Okay, so think of a ladder. We've all seen a ladder before. The steps on a ladder represents latitude. Okay, they're flat, they're horizontal, latitude. Okay, as you work your way up from the equator, you're heading towards north, and as you're working your way down from the equator, you're going south. Okay, so the purpose of latitude, again, measure the distance, how far you are away, north or south, from the equator. Okay, again, flat lines, horizontal line. Note that these lines are the same distance, especially in this picture right here. Okay, see how the lines are the exact same distance apart in terms of measurements. Okay, so that's latitude. Latitude. Again, can't emphasize it enough. Please make sure we know and understand what the purpose of latitude are. Okay, so let's spend some time now and look at longitude. Okay, longitude, again, they are imaginary lines on our globe, on our map. They are not the same distance. Okay, they are not the same distance apart, which means that they are not parallel. Okay, latitude, parallel, longitude, not parallel. Okay, not parallel. They meet at the poles, so they start at the North Pole and the South Pole. It goes all the way down. Okay, that's where they meet. And the purpose of latitude is used to measure the distance east or west of the prime meridian. Again, we know what the prime meridian is, we define it. So the longitude is used to measure how far you are in terms of east or west of the prime meridian. Okay? Again, longitude, not parallel, not the same distance. They run up and down. They are vertical lines. Okay? They are vertical lines. They start at each of the poles, north or south pole. It goes all the way down. That's where they meet. Okay? So, again, I got pictures to further illustrate. So, again, think of the prime meridian. Again, we know the prime meridian is down the middle. So, in terms of this picture's right here. Okay, it meets at the North Pole and it meets at the South Pole. That's where each of the longitude lines starts and begin. Okay, so note that each longitude lines, they start at the pole and they go all the way down. They are not the same distance. Some lines are greater and smaller in terms of distance, but in terms of longitude, they are used to measure how far you are away from the prime meridian, whether you're east, going back to our sense of directions, or west of the prime meridian. How far you are going away from the prime meridian. Okay, so again, think of a ladder. Okay, picture a ladder. The legs on a ladder represents, in this case, longitude. Okay. Again, they are also used to measure in degrees, similar to on a protractor, measuring angles. Again, similar to the equator, the prime meridian is at 0 degrees. And as you go further away, it just increases the numbers in degrees. Okay? So longitude, latitude, okay? Please make sure we know and understand and be able to differentiate the difference between latitude and longitude. Okay, if you are confused or having trouble defining which is which, just let me know. Okay, Facebook me, call me, email me, and I will be more than happy to explain it during my office hours. Okay, so but again, we need to understand the difference between the two. Again, if you are able to use your math knowledge in terms of the y-axis and the x-axis in terms of looking at in terms of a grid, that should help too. Okay, so many ways, many tricks in terms of remembering the difference between latitude and longitude. Okay, so again, more pictures to illustrate the difference between both. Okay, again, a lot of students have trouble remembering which line is which. They understand the concept of latitude and longitude, but they don't have a hard time remembering the difference. Okay, some people may be confused. Okay, so again, I'm going to emphasize it. Can't emphasize it enough. Again, this line, this black line on this picture, I'm going to draw in black. Yeah, I'm throwing in black. It's the equator. Okay, it's the equator. Okay, lines that goes horizontally that are flat, they are latitude. Okay, latitude lines. Okay, again, vertical line down the middle, prime meridian, and lines that are vertical are longitude. Okay, latitude lines are used to measure how far you are away from the equator, whether you're north or south. And longitude, think of longitude, it's used to measure, helps with the prime meridian, how far you are either east or west of the prime meridian. Okay, whether you're moving closer or away, helps us to find where we are. Okay, again, this other picture on the right hand side, same thing. Okay, again, please make sure we understand the difference between the two. So let's put it all back into your content or context. Okay, so again, picture a globe. We know a globe is not a square, it's not a rectangular prism, it is a sphere. Okay, it is a sphere, just like a tennis ball, just like a basketball or a baseball, it is in a sphere shape. But if we were to take the Earth or the map and unravel it, make it super flat, it will look something like this on my screen. Okay, and then we throw coordinates on it, throw a grid system on it, and boom, we have these imaginary lines that are actually not there, but they're just there. Okay, these imaginary lines are known as latitude, longitude, prime meridian, or the equator. Okay, so I think I have a bigger picture of this. I do. And let's look at it into bigger content. Okay, can anyone point to the equator on this screen? If you point towards the middle of the map, you're correct. Right here, this is the equator. Okay, maybe I should draw in a different color. Let's pop it in Red. Red? Let's throw it in red. So this red line right here is the equator. Is the equator. Okay. Can anyone point or draw on the prime meridian? Okay. Think of the middle of the map. Think of a vertical line. And if you drew something that looks like this, you are correct. This is the prime meridian. Okay, so what's in red? The equator, and what's in green is the prime meridian. Okay? So can anyone draw on any latitude lines? Okay, I'm gonna throw it on red as well. Okay, again, think of flat line, horizontal line. Okay, so any of these lines right here that I'm gonna draw in red, they are latitude. Okay, latitude. Okay, and as we go up, same thing. Latitude. Okay, and these lines in red are examples of latitude lines. Okay, and again, longitude, I'm going to throw in green, are these lines right here. Starts at the pole, goes all the way down. Etc. Okay, these green lines that pretty much looks like they're longitude lines. Okay, note that the red lines, note that my lines is not straight because I drew it in a pen, but they are the same distance apart. They are parallel lines. Okay, they're same distance apart. Okay, note that the values on the side increases the same distance. Okay, which means that they are the same distance apart. Okay, get to more of that in a second. Whereas the green lines, the longitude lines, they are not. Okay, note that these lines are straighter, these lines are wider. Okay, are longitude lines. Okay. Uh, Makes sense? So that's what latitude and longitude looks like in terms of on a map and on a globe. Okay? So let's erase all this. And we'll get to looking at how to measure latitude, longitude lines in terms of degrees. Okay? Alright. So this map right here, this little picture right here, is great because it has, again, like I said, the equator, the prime meridian. It has different continents, different bodies of oceans, and on the sides of this map, sorry, it simply has the measurements in terms of latitude and longitude in terms of in degrees. Okay, degrees. Okay, there's that little fancy circle that's located on the right top corner. Okay, so as mentioned again, the equator and the prime meridian are 0. Okay, 0 degrees, 0 degrees. Okay, 0 degrees and 0 degrees. Okay, that's our starting point. Okay, so in terms of latitude lines, anything above the equator, again, we know it's north. But the values, okay, they just measure in degrees. Okay, for example, 20, 40, 60, 80, etc. Okay, note that they are in north. Okay, north. Okay, and as we go below the equator, again, same measurements in degrees, but they are measured in south. Whereas on the other hand side, the latitude, again, still measured in degrees, but they're measured in east or west. Okay, 60 degrees, 100, 140, 180, and that's east. And as we move away, okay, same thing, 60, 100, 140, 80 degrees, but it's measured in west. Okay, so both latitude and longitude still using degrees in terms of how far you are away, but we need to plug in our sense of directions: north, south, east, or west. North, east, south, west, and for each shredded wheats. Okay. Let's get into further details about that. Yes, we know there's lots and lots about latitude and longitude. Can be confusing, but once we understand the difference between the two, we're good to go. Okay, so writing latitude and longitude. Okay, this will come super handy in terms of assignment number 16. Okay. So writing latitude and longitude. So we need to write latitude and longitude in this way. And it has to be in this way always, just the way it is. And it needs to be written in this way if we want to get full marks. So to write latitude and latitude lines comes first, followed by the latitude lines. Okay? So latitude comes first, followed by longitude lines. So we need to write latitude. We know that latitudes are either north or south. And longitude are east or west. Okay? So for example, it needs to be written in this way. It could be, for example, 20 degrees north, followed by a comma, and it could be 75 degrees east. Okay? However, if you wrote as in 20 degrees east, sorry, degrees, don't forget that unit, and 75 degrees north, you are incorrect. Okay? Because the directions of the degrees are incorrect. Okay? In this case, whatever written in blue, you wrote longitude first, followed by latitude. Okay? Incorrect. Okay? So, to make sure, here's a little trick. On the left hand, wherever you write first has to be either in north or south, followed by whatever's in east or west. If you wrote east or west first, followed by north or south, again, you're incorrect. Okay, so please make sure you know that difference. Okay, so it always has to be north or south first, followed by east or west, which means that latitude comes first, followed by longitude. Okay, that's how we write it. So now we need to know how to find it. Okay, I'll come back to this when we're going back to assignment number 16. So let's do a little example. So on my map, on my screen, I have a map of, can anyone tell me that province? You just said Quebec, you're wrong. Well, Quebec is there, but on my map, I got a map of Ontario. Ontario, our province right here. And look at that. It has Snooze Factory, Ottawa, Toronto, Sarnia, Thunder Bay, and Dryden. Okay? So let's do a little exercise, a little activity together where we have a little bit of practice in terms of how to write and how to locate using longitude and latitude. By using this knowledge, we can find the exact location of Dryden or any place on the map for that example. Okay, so in terms of Dryden, okay, pretty close to Sioux Lookout. Okay, so we need to look at latitude first. Again, latitudes are flat line, lat for flats, and they are horizontal line. Okay, so we can look at this line, where it's in green, this line, or this line. So in terms of Dryden, it's right here. Let's draw an imaginary line that goes across. Okay, in terms of our values, let's look at our scales on the side. It has to be between 48 north and 51 degrees north. Okay, so in this case, we can say it's about 50. We'll call it about 50.5, give or take. Okay, because there's 49 and there's like 50. Okay, so for example, Dryden in this case can be, we'll call it 50 degrees. Okay, just for example in this case. In terms of direction, we know it has to be north or south because we're looking at latitude. In this case, how do we know is simply on the scales. So since they are all north, it's going to be 50 degrees north, followed by a comma. Now we need to look at longitude lines. Again, longitude lines are vertical lines. Okay, it could be this line, could be this line, and it could be this line. Okay, so in terms of looking at Dryden once again, oh Dryden, okay, it's pretty much touching or on the line right here. In this case, 93 degrees west. Okay, how do we know it's west? Because it tells us on the top that it's west. Okay, which means that's west of the prime meridian. Okay, so the exact location, for example, well, estimating on this map, Dryden is 50 degrees north, 93 degrees west. Okay, we plug that into our latitude and longitude systems in terms of coordinates, we can get that exact location. Okay? So, that's how we write and locate latitude and longitude lines. So for example, here in Sulikout, if we were to write the exact location of Sulikout that I found earlier, so Sulikout, Ontario, where we live, right here. Okay, the exact location is 50 degrees 0978 degrees, that's north, followed by the longitude, which is 91.9220 degrees west. That's the exact location of Sulikout. So 50 degrees north, it's below right here, and 91 degrees is probably around somewhere right here. Okay. So that's the exact location of Sulikout. Okay. In terms of looking at latitude and longitude. Okay. So that's how we go back to my original question where I posed how to find exact location if you were to tell a friend the exact location of Sulikout, Ontario, in terms of latitude and longitude, 50 degrees, 50.0978 degrees north, and 91.9220 degrees west. That is the exact location of Sulikout, Ontario. Okay? So we're pretty much at the end of today's class. We will continue this on Thursday. So I will go over questions on assignment number 16 the last one on Thursday coming up. Okay, and also this coming Thursday is our last class for this term. I will go over some examples of questions that you can look for or expect when writing your exam or writing your tests. Okay, I'll talk more about that on Thursday. Okay, expectation for the tests, what you can expect, how it's conducted, what you need to do in order to pass, and what questions